So yesterday we talked about inverse functions. Inverse functions. Inverse functions are part of the reciprocal function family. Okay, they're your introduction to reciprocals. And so what we're going to do is dive in and analyze reciprocal function. So if you look right here, our reciprocal function in its general form, it's going to be y equals a over x minus h plus k. Okay, where a cannot equal 0, so a is not going to be 0, and x and h cannot equal each other. Okay, the graph of this equation has what we call horizontal asymptotes and a vertical asymptote. Remember, from an asymptote is an imaginary boundary line. It's going to be an imaginary boundary line. And we have a vertical one and a horizontal one. Our horizontal is at y equals k, and our vertical is at x equals h. How many of you remember from Algebra 1 your teacher ever saying the term oi vux? Or do y'all remember oi vux? Okay. So let's just kind of generally review that. Oi stood for horizontal, right? You had a horizontal line. It has a 0 slope, and the equation is always y equals, right? Horizontals are going to always be y equals. Vux is your vertical line. The slope is undefined. Let me write that a little better.
Wait, does it say 4 O slope? Oh, 4.
Undefined, horizontal. I didn't feel like writing the whole word out. Vertical, undefined, and the equation is going to always be x equals. Okay. It stands for 0 slope. Okay. I remember learning this in 8th grade and using it as my math cuss word in class. So anytime something didn't go right, I was, oi bucks. It got on my 8th grade teacher's name, you know, typical 8th grade annoying child. And so that's how it's been stuck in my head since 8th grade. Oi bucks. All right. I think I'm saying oi. Oh, I think I'm saying the H, poi. I'm not saying it.
I was like,
Poi bucks. All right. So, with that being said, that's why your horizontal asymptote is y equals a value, and your vertical asymptote is x equals a value. Okay. Guys. So the two members of the reciprocal function family are our inverse variation function. So inverse variation, which we talked about yesterday, was y equals a over x. Yesterday we did it in terms of k equals x times y, and then it became y equals k divided by x. Do you remember that? Okay, that's our inverse variation function. The difference here is that they just used an a as your k. Okay, where a is 1, h is 0, and k is 0, this is called our parent function. So the parent reciprocal function is y equals 1 over x. That is our parent function. That means this is where everything stems from. So everything starts here with y equals 1 over x. So if you look at your graph here, so you have your graph f of x equals 1 over x. We're going to use this to learn the basic attributes of a reciprocal function. So the first thing that we're going to highlight is the fact that there are asymptotes. So in here, we said we have an asymptote, a vertical and a horizontal. Our vertical asymptote is right here. And it's going to be at x equals 0. Our horizontal asymptote is right here. And it's going to be at y equals 0. Okay, they're imaginary. So when you graph them, are you going to see them on a calculator or on anything? No. Because it's a vertical line, and vertical lines equations are x equal because it's going through the x-axis. Yes.
This is not changing.
Okay. Notice here that because we can't touch our X and Y axis, that there are no intercepts, right? Okay, now when you're defining your domain, you're gonna keep in mind that for my domain, I can't touch any of my X, I can't touch X equals 0, right? So my domain has to include the fact that X cannot equal 0. Do we see that? So X cannot equal 0, and how we write that using interval notation, it's gonna be 2 parts. When you are doing domain, it's from left to right. All the way to the left is called negative infinity. So I'm traveling along. Oh no, I can't get to the other side. What do? You stop. So my domain is from negative infinity to 0. Notice I use a parenthesis because there's an asymptote and it's not included, right? This is our or symbol, or our domain is from 0 to positive infinity. So my number can be between negative infinity and 0, or between 0 and infinity.
So is that 0 to infinity the top right quadrant?
Yes.
So why would it be positive infinity to 0?
Because you read from left to right and you start at 0 and then head to infinity.
Well, that's like we not know we don't know if it's 0 though.
We are starting at 0. We don't touch 0. That's why it's a parenthesis, not a bracket.
So what's that like you?
That's our or. Okay. And the same thing is happening with our range. Our range goes from bottom to top. All the way to the bottom is called negative infinity. As I'm going up, I'm going. Oh no, what stops me? 0. So the same thing is y cannot equal 0. So when I write it in interval notation, please stop. You're like right here in my ear. It's going to be from negative infinity to 0, 0 to infinity. Still, because of this asymptote. Your restrictions change as your asymptotes change. So if my asymptote moves, guess what? So does that 0, what it cannot be. For this one, are there any intercepts? No. Because it can't touch the x-axis or the y-axis, so I can't have any intercepts. But I do have asymptotes. I have a vertical at, where's my vertical at? Vertical's at x equals 0. And your horizontal is at y equals 0.
Wait, so is that just for every one of them can have that?
An asymptote?
Like a vertical panel stuff?
Mhm.
Are they all gonna be like, what would it look like if the y equals 5?
We will. It's in our notes. We're getting there. We just got to make sure you understand the parent before we give you other things. Okay. Lastly, this function is considered an odd function. So this is an odd function. And it's a unique odd function because technically, does it go through the origin? It technically doesn't go through the origin, but if you were to rotate your paper 180 degrees, does it still look the same? It does. Okay. Our origin is being counted as where our asymptotes are at. That restriction is. All right, so we're going to practice graphing what I like to call the children version of this parent function. Okay. What I call the children is that I'm only going to change the numerator. Okay. The grandkids, you get all your H's and K's changed, but for the kids, we're just changing the numerator. Okay. Here are the general rules for graphing a rational function. Step 1 is you're going to rewrite it in the general form and identify your A, your H, and your K. Step 2 is identify your horizontal and vertical asymptotes, remembering that your horizontal asymptote is going to be your Y equals K. Your vertical is going to be your X equals H. And with your X, you need to remember that X's are liars. So if it says X plus, it's actually a negative H. If it says X minus, it's actually a positive H. Okay. Our general form, I'm sorry I didn't write it, is going to be Y equals A over X minus H plus K. That's general form. Next, you're going to make a table of values. When you're choosing your table of values, you want to choose values that make it easy for you to do basic multiplication. Okay. And then lastly, you're going to state your domain and range. So let's dive in. What is there? It's at the top of your page. Also.
Oh, is that 8?
Okay, so starting here, we're going to go through the steps just together. So step 1 is to make sure it's in standard form. This is in standard form. Just to make it very clear to you, this is -5 over x minus 0 plus 0. Because if there's nothing there, then what has to be there? 0. Because I can add and subtract 0 and it doesn't change the problem. Does that make sense? Okay. Step 2 says to identify your asymptotes. So my vertical asymptote is going to be whatever x equals h. And in this case, it's going to be x equal 0. My horizontal asymptote is going to be y equals my k. And what is my k value? 0. When you put in your asymptotes on your paper, you either can highlight them or use a dashed line. If you choose to use the dashed line, it's just dashing out the line. So do. So typically when you're graphing by hand, asymptotes are represented with dashed lines or highlightation or being highlighted. Okay. I don't even know if highlightation is a word, but it came out very smoothly on its own. All right. Step 3 is to create your tables of values to help you plot. So I'm going to choose x values that plug in nicely into y equals -5 divided by x. You don't need large numbers. That's why our graph doesn't go very high. Something that plugs in pretty nice here is -5.
Wait,
It equals 1.
oh, -5 by -1.
That plugs in pretty nice. I could do -2. It's going to be 2.5. That's pretty easy to graph. I can do -1.
That'd be
5. And I could do their opposites. The opposites of negatives are their positives, right? 1, 2, and 5. The difference is what's going to change.
Wait, couldn't we just do like 1, 2, 5, and 5?
Say that again.
For our x equals 1, 2, 1, 2, 5, and 5 would be 6. I would like an inverse.
Yeah. Okay, so I'm going to plot these points and create my sketch. So if I go to -5, 1, 2, 3, 4, 5, I'm going to go up to 1. I'm going to go to -2. I'm going to go up to 2.5. I'm going to go to -1. And you should be able to plot points without looking at me. So if you're depending on me to plot points, we got a problem. Okay. So then I'm going to go to 1, and I'm going to go to 1 and then go down to -5. 1, 2, 3, 4, 5. Go to 2, go down to 2.5, 2. And then I'm going to go to 5. 1, 2, 3, 4, 5, and go to -1. Okay. Once I have my points, I'm just going to follow the asymptote out. And there is my rational function. My reciprocal function graph. Because my asymptotes haven't changed, my domain and my range are still from -infinity to 0 or 0 to infinity. So I'm going to give you the next 5 minutes at your table to practice these 4 steps on the practice problems 1 and 2. As you're practicing, if you need help, please let me know. I will gladly assist you. I'm pretty trained to those, so no, I'm saying that. All right, so for here, this is already in standard form. I can already tell, I can look and see what my asymptotes are at, right? So I know that there's no h, so x equals 0 is going to be my vertical asymptote, right? There's no k, so y equals 0 is going to be my horizontal asymptote. Agree? So I'm going to go ahead, I'm going to highlight them just so you can see where my boundary lines are a little better. I don't know what it is with me drawing straight lines up here. I promise on paper, I draw straight lines.
How did you know that y equals 0?
Because there's no k value. There's nothing being added or subtracted. Okay. Next, then we're going to choose points that work well. So when I'm creating my table, what are good y values that are going to work here? Yeah. So you could have started with -9, -3, -1, 1, 3, and 9. Those are going to be my easiest ones to work with, right? So 9 divided by -9 is going to give me -1. 9 divided by -3 is going to give me -3. And then we have -9, +9, 3, and 1. Okay, that's an attribute of being an odd function. The opposite x value is going to have the opposite value. All right, so we're going to plot -1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Pew. -3, 1, 2, 3, down 1, 2, 3. And then -1 down to 9. I'm going to say that this is 9. Hopefully 1, 2, 3, 4, 5, 6, 7, 8. Oh, I did it. All right, and then I'm going to connect my little pointy points. Pew, 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 pew. Okay, same thing over here, but this time I'm going to go to 1, 9, 1, and up to 9. And then I'm going to go to 3, 1, 2, 3, up to 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, and up to 1. And this is what your graph should look like. Okay, what's the domain and the range here? Perfect. Okay. All right. When you got to number 2, notice it wasn't in standard form, was it? It was actually in variation, right? Our k value. So first thing you have to do is put it into standard form. So y equaled 2 over x. That's it. Step 1 done. Step 2 is to identify your asymptotes. So our horizontal asymptote and our vertical asymptote, they're at 0. So we have x equals 0, and I wrote that backwards. Horizontal is y equals 0, and vertical is x equals 0. So I'm still boundary line. Boundary line. Okay, choosing friendly values here. So for your table, so that y equals 2 over x is an easy number to work with. Exactly. I'll stay in that range as well. And that's going to give me -0.5. Then I have -1, +2, -2, I meant to say, -2, +2, and then we have +1 and +0.5. So plotting those points, 1, 2, 3, 4, going down a half, -2, going down 1, 1, going down -2. Okay, repeating it on the other side. So at 1, we're at 2. At 2, we're at 1. And at 4, we're at a half.
Wait, okay, I still don't understand about domain. If we don't see it at 0, why wouldn't it be on both sides?
It does go to infinity. It just has to stop and then continue. You literally are stopping your graph.
Oh, so they're like the same line.
That or is like you're saying I have to stop and then I continue to infinity. Okay. All right. So looking up here, how did we do?
So are these always gonna be like that? Cause when would it ever not stop?
What do you mean?
With this type of graphs, it would never not stop.
Yeah, it goes on.
So we can already see whenever it looks like this, but it's gonna be negative infinity to 0.
No, your 0 can move. It's about to move.
But whenever it doesn't have, whenever the VA and H are 0.
Yeah. All right. So what we worked with were our reciprocal functions with our asymptotes being at zeros, right? Now that can move, they can shift. That's called a translation. Okay. They can translate horizontally or vertically, correct? So when you translate, that means that your asymptotes are going to also do what? Translate. Your asymptotes are going to move as well. Okay. So if you look right here, the first thing we're going to do is when there's a negative in front, it applies to the numerator. So it's going to actually, it's y equals -6 over x plus 3 plus 2. That negative is applying to the numerator. So what we're translating is -6 over x. But from here, we're going to identify our asymptotes. So here's our standard form. Our asymptotes are what our x and what our h and our k are. Your x equals your h. It's going to be -3. X equals -3, exactly. Because if I plug -3 in the denominator, it's going to make it equal to what? No, if I plug -3 in, it's going to make it equal to 0. And you can't have 0 in the denominator, it's undefined. That's why it's an asymptote there. Okay? Because I can't use that value. Does that make sense? And then your y equals your k. And what is our k now? It's just 2. Y doesn't lie, only x's. Okay, so x equals -3. I'm going to go 1, 2, 3. Uh-oh, my pen is being weird. I'm trying not to cheat and use the line tool. And then y equals 2, so I'm going to go here. We're translating the graph. We're creating our boundaries, exactly. If that makes sense in your head. All right, so then now I have to choose values, but my values are centered around where I'm at here, okay? So keeping that in mind, it is centered around here. You can either choose values or the other option is thinking about if I just had the function -6 over x, right? And with -6 over x, it's going to start where? What, I mean, if it will be if I had 1, where would 1 be at? It would be at -6. So if I was here at 1, I would be down here at 1, 2, 3, 4, 5, 6. And my asymptote would be at 0, 0. However, I have to shift this point just like I shifted this.
Yeah.
Does that make sense?
Yeah.
Everything is going to shift. So instead of being at 1, -6, I have to go to the left 1, 2, 3, right? And then I'm going to be shifting up 2. So it's
Instead of doing that though, just orient on your plotting the course, you orient around the boundaries instead.
Yeah.
Like pretend like the
yes.
like pretend like that's the origin and the intersection and then like
Yeah, you could still choose points. I'm saying if you didn't want to choose points and create a table, I was giving you another option. We're still going to make the table. What I wanted you to see other options. Okay. So the other option is here. I can say, okay, I'm going to take the fact that at -6 over x, I would have been here. And I'm just going to follow the transformations to follow my asymptotes, which means I can go over 3, up 2, and here's my new point.
wait, so why would yeah, -6 1?
If I plug x into here, if x equaled 1, what is y going to equal? -6.
Just like making that table.
Yes, I was just showing another, before we made the table, I was just trying to draw the connection between this and the other function. Okay, So that's an option in moving. The other option is creating a table and choosing the points around that around your new asymptote, okay? So when I'm making my table, the trick here is that your numbers aren't as friendly to pick correct numbers. Does that make sense? So when I'm choosing the X values, okay, yes, I can choose, what is this? 1, 2, 3, -3. Am I at -3? I'm at -2. If I plug in -2 into this, that's a lot of work to do, right? I mean, you can do it if you're good with mental math, it's gonna go fairly quickly. You're like, boom, bam, thank you, ma'am. But
That would be, it'd be 4.
it's a -2.
Yeah, so we plug it in for X.
How is that a 0? -2 plus 3?
Oh, I thought that was a 2, it was like a 2. Yeah, I thought that was a 2. I was so confused, but even if it was, oh, negative.
It's a 3.
Okay.
Sorry.
Okay, yeah,
I was like, it gets me 1. If I plug in -2, I'm gonna get what? 1. And -6 divided by 1 is? -6 plus 2 is? Am I at -4? Yes. Okay, so you have two ways of doing this. You can think of it as its own table, or you can think of it from the rational and move those points of the rational. Of the reciprocal and move those points. Which I guess we will resume on, what's that day called? Monday. So we
I
don't,
can't believe we don't.
It's better like without a table.
I prefer without a table, but some people need that visual.